Dear students, welcome to our new course Circuits and Networks. I am Deepak Vedev, Assistant Professor from Vidya Academy of Science and Technology. In today's video, we will discuss about basics of electric circuits. This will be helpful for your study about the subject circuits and networks. So, we will be revisiting some of the topics that you already studied in your basics introduction course to electrical and electronics engineering. So these are the topics that is covering in today's video, that is Ohm's law, Kirchoff current law and Kirchoff's voltage law. So what is Ohm's law? Ohm's law simply states that the current flowing through a conductor is directly proportional to the potential difference applied across its ends, provided the temperature and other physical conditions remains unchanged. So mathematically we can say that voltage across any conductor is directly proportional to the current flowing through the conductor, or V by I is a constant. That constant is usually represented by the letter R, resistance. Now let us try to understand Ohm's law by using some examples. The circuit is a simple circuit. Here a battery of 5 volt is connected across a 5 ohm resistance. You have to find the current through the resistance. So according to Ohm's law, we can say that voltage by current V by I is equal to resistance. Actually, the voltage across the resistance, here the 5 ohm resistance is 5 volt. So current can be found out by the relation I is equal to V by R. So voltage is 5 volt by resistance 5 ohm. 5 volt by 5 ohm. That is 1 ampere. It's a simple problem. So next we have to find, in this example, there are two resistors that are connected in parallel. You have to find the current supplied by the source. Here also, the voltage across each resistance is 5 ohm because both of these resistors are connected in parallel to the voltage source 5 volt. So how to find the current supplied by the source? So in order to find the current, we have to first find the current through the resistors. We know that the voltage across each of these 5 ohm resistance is 5 volt. So we can find the current through the resistors by using Ohm's law. So what is I1? I1 will be equal to voltage across the resistance 5 ohm divided by the value of resistance. That is 5 volt by 5 ohm. So I1 will be 1 ampere. Similarly I2. So I2 is the current through 5 ohm resistance. To find the current I2, you have to know the voltage across 5 ohm. It is also 5 volt. So the current I2 will be equal to 5 volt by 5 ohm. That is also 1 ampere. Thus, the total current, the current supplied by the source, you can find by simply adding I1 and I2. So I1 is 1 ampere and I2 is also 1 ampere. So the total current supplied by the battery will be 2 ampere. You have to remember that in the previous case, the current supplied by the battery is 1 ampere. But in this case, the current supplied by the battery is 2 ampere. So by adding resistance parallel, the effective current supplied by the battery is also increased, which means that the resistance seen by the battery is reduced. That's why the current supplied by the battery increases. In this example, we also use another important law that is governing the current flow of electric circuits. What is that? Here we written that I is equal to I1 plus I2. It is also a law that is known as Kirchoff current law. What is Kirchoff current law? The algebraic sum of currents meeting at a junction in an electric circuit is 0. So, at any node or at any junction, algebraic sum. What you mean by algebraic sum? It is nothing but you have to consider the side of the current. If the currents are entering, usually it is known as incoming current. If the currents are leaving, that are known as outgoing current. So incoming current is equal to outgoing current. So here we are considering the nature of the current. That's why it is known as algebraic sum. So here in the figure, two currents I1 and I2 are incoming currents and I3 and I4 are outgoing current. So simply we can say that I1 plus I2 is equal to I3 plus I4, or I1 plus I2 minus I3 minus I4 is equal to 0. That is algebraic sum will be equal to 0. So this law we already used in the previous example. Now let us consider another example. This circuit is a modification of the previous problem that we discussed in Ohm's law, in the application of Ohm's law. Here there is additional resistance. We have to find the current supplied by the battery. So how to find this current? As in the previous case, we cannot find I1 and I2 directly. What is the reason? Here the voltage across the parallel 5 ohm resistors are unknown, and the voltage across the 5 ohm resistance series with the battery source is also unknown. So we cannot directly find the currents I1 and I2. Here also the total current I will be equal to the sum of I1 and I2. But we cannot find I1 and I2. That is the problem with this circuit. In order to analyze such circuit, we have to use another law. One more law, that is Kirchoff voltage law, is also needed. So in such circuits, you can find the current by using different method, either by resistance reduction techniques or by using Ohm's law, Kirchoff current law and Kirchoff voltage laws, or using mesh analysis, node analysis, or using networks theorem. We will be studying these networks theorem in detail in our first module. The mesh analysis and node analysis techniques you already studied. We will discuss in these coming videos. So how to find the current supplied by the source? The first method is reduction, network reduction. Here we know that the 5 ohm resistors, there are two 5 ohm resistors that are in parallel. So if two resistors are in parallel and their resistance values are same, you can find the effective resistance. Or if two resistance R1 and R2 are in parallel, the effective resistance will be R1 R2 divided by R1 plus R2. By using the similar method, the 5 ohm, here the two 5 ohm resistors are in parallel, you can find their effective resistance as 2.5. So the network in the left of this slide can be reduced as in the network that is shown in the right side. Thus we reduced the networks. These two networks are identical networks. Actually here we reduce these two 5 ohm parallel 5 ohm. The effective resistance will be 2.5 ohm. Okay, in this circuit, in this simple circuit, you can find the current supplied by the battery, because these 5 ohm and 2.5 ohm are in series, and the voltage across the series combination of these two resistors is 5 volt. So by using Ohm's law, we can simply find we can simply find the current through the current supplied by the battery as 5 volt divided by the effective resistance 7.5. 5 by 5 7.5 will be the current supplied by the battery. This is a method of it is the method of resistance reduction technique. This method can be used if the circuit contains only a single source and the remaining network constitute only the resistance or inductor or capacitors. So this is the first method, that is solution by network reduction. Next, let us try to understand what is Kirchoff voltage law. In any closed path of electric circuit, the algebraic sum of all electromotive forces and the voltage drop in the resistance will be equal to 0. It is the simple statement of Kirchoff voltage law. Here also we say the algebraic sum, which means that we have to consider if the voltage is raised or voltage is dropped across the element. Okay, so here in the figure you can see a simple circuit, a simple mesh or simple closed loop in a which is a part of a large network. So ABCD is a simple loop in a circuit. How to apply Kirchoff voltage law? In order to apply Kirchoff voltage law, you have to first mark the polarity of the voltage drops across the resistance. That voltage drop, the polarity of the voltage drop depends on the current flow. In the resistance R2, the current I2 is flowing from A to B in this direction. That's why here in this end we marked a plus, and here current is leaving and we marked a minus sign. That's how, depending upon the current direction, we have to mark the polarity of the voltages. Here in the case of R3, the current is flowing from C to B in this direction. That's why here at the entering side we marked a plus, and the leaving side we marked a minus sign. Similarly, you have to mark the polarity of the currents in each of the resistance. And for electromotive force or for the battery, the polarity will not change, or it does not depend upon the current flow. For battery E1, the polarity is in here plus and here minus. And for E2, here it will be plus, and lower side it becomes minus. So after marking the polarity, you have to apply the Kirchoff voltage law, and the Kirchoff voltage law you can written as E1. We started from one end. So for writing this equation I started writing from the point D, and D. When starting from D, first I found the voltage is rising. That's why first E1 is positive, and there is a voltage drop. Plus to minus means it's a voltage drop, and the voltage drop is I1R1, and here again there is a voltage drop, that is I2R2. So minus I2R2. Then here in the resistance R3, the voltage rises from this end to this end, and the voltage, the value of voltage across resistance R3 is I3R3. That's why I3R3 is positive. I3R3 is positive. And again here another voltage is there, and if you are travels in this direction, the voltage is dropping. That's why E2 is taken as minus E2. Again when we reach R4, and we are traveling in this direction, and again the voltage is rising across R4, and that voltage is I4 into R4. So you will get this equation: E1 minus I1 R1 minus I2 R2 plus I3 R3 minus E2 plus I4 R4 is equal to 0. This is how we apply Kirchoff voltage law in a network. Okay, so now let us find the current I. This is the same problem that we discussed earlier. So we have to find the current supplied by the battery using Ohm's law and Kirchoff laws. So sorry, here I forgot to include the 5 ohm resistance in series with the battery. So actually the problem is this: you have to find the current supplied by the battery I. So current will be equal to I1 plus I2. We cannot directly apply Ohm's law since the voltage across each resistors are unknown. So what we will do, you can mark the polarity of voltages depending upon the current direction. In here, in the first 5 ohm resistance, when we consider the current is flowing from this side to this, so we marked here plus and here minus. Okay, sorry. Next, here also for this 5 ohm, the current is traveling from this point, this node to here. So we marked in this side plus, here minus. Where the current ends, that side we will mark plus. Where the current leaves, we mark negative for the voltage. Similarly, we mark the polarity of the voltage across 5 ohm resistance. After marking these polarities, you can apply Kirchoff voltage law in the two loops. Here there are two loops or two meshes are there. What are those? You can apply for any closed path. You can apply Kirchoff voltage law in any closed path. So here I am considering this closed path and this closed path. This is not the mesh analysis. We are only applying KVL, Kirchoff voltage law. Or you can use this outermost closed path. Anywhere you can apply KVL. Thus our first equation is I is equal to I1 plus I2. It is nothing but the Kirchoff current law. So in this problem there are three variables. There are I, I1 and I2. We need three equations. We obtained the first equation as I is equal to I1 plus I2. Next two equation we will obtain by using Kirchoff voltage law in two loops. So in the first loop you can write the Kirchoff voltage law as minus 5. Actually you can simply write the Kirchoff voltage law by using a simple technique. Here if you consider the first mesh, that is this one, for this first mesh, that is first mesh or first loop, how to write KVL in a faster way. I am starting from this side here. When I traveling from this point to here, I first find negative sign. That's why I written here as it is at minus 5. It is the voltage, that is minus 5 voltages. Then when I travel towards the first resistance, that is 5 ohm resistance, I am finding the polarity, first polarity as positive. Here I am finding positive first. That's why I am taking the next voltage across the 5 ohm resistance is 5 into the current 5 ohm. 5 is the value of resistance and the current is current flowing through this 5 ohm resistance is I. So the voltage is 5 into I and I am taking it as positive. It is because when I reaches here I am first finding it as plus. That's why I take here plus 5. Again, when I travel towards this resistance, I am also seeing first the positive sign. That's why I am again use this positive sign to describe the voltage across this 5 ohm resistance. The value of that voltage is 5 into current through the resistance, that is I1. 5 into I1, that is this plus 5 into I1, and it is equal to 0. So let me explain it again. In the first loop, when I travel from here, I am first finding the negative polarity, and the value of that voltage is minus 5. That's why I am writing here minus 5. And then when I reach the second element, that is 5 ohm resistance, I am finding first the positive sign, so I written the plus sign here, and the voltage across that resistance is current into resistance, that is 5 into I. So I written here 5 into I. Again, when I reach the next resistance, I am seeing plus sign first. So again I written here plus 5, and the value of the voltage is 5 into I1. 5 into I1. I1 is the current through this 5 ohm resistance. Okay, that's how I obtained this KVL equation. Similarly, we can apply the KVL in the second loop. I am starting from here. When I reach the first resistance, I am seeing first the negative sign. That's why I written minus here. And the voltage across this 5 ohm resistance is 5 into I1. So the magnitude is 5 into I1. Again, when I reached here, I am seeing the positive sign, that's high, why I am writing plus here, and the value of the voltage here is 5 into I2. So I written here 5 into I2 equal to 0. Thus now we have three equations. First one is by using Kirchoff current law, that is I is equal to I1 plus I2, and the second equation is by using Kirchoff voltage law in the first loop, minus 5 plus 5I plus 5I1 is equal to 0, and the third by using KVL in the second loop, that is minus 5I1 plus 5I2 is equal to 0. By solving these three equations, you can find the value of I and I1 and I2. Thus, in the today's class, we discussed about different laws, basic laws that are governing electric circuits. First, we discussed about Ohm's law, then Kirchhoff current law, and Kirchhoff voltage law. And we also studied how to solve the problem using network reduction method. Okay, thank you.